Hello, this is my solution to Project 4, where we were to implement two page replacement algorithms on FIFO and uh, least recently used page replacement algorithms. And so we'll walk through the code. So we have an is in array method, and it checks whether a given page is currently loaded into the frame. Uh, it iterates through the frames, and um, if the page is found, then it returns the index, and if the page is not found, it returns -1. And so this is a helper function used by both the FIFO and the LRU algorithms. Then we'll go down to the second one. It should be create. I'm going in order. Yep, create RS. And this function essentially um, generates a reference string and is a sequence of page numbers to simulate process memory access. And this method it uses a locality model. It processes tend to access nearby memory pages, and it start marks the center of the current locality. And for each iteration, it generates rate of motion random pages within the locality, and it has a with the prob probability randomly jumps to a new locality. Otherwise, it shifts the locality by 1, and there's a modulo the virtual memory size, and this is a realistic reference string that allows us to test the page replacement algorithms. Next, we'll go to our FIFO replacement algorithm, and this is the first in, first out. It basically it stores a frames array with the pages currently in memory, and so the oldest tracks the next frame to replace, and for each page in the reference string, if the page is not in memory, what it does is it will cause a page fault, and then replace the oldest page, and then move the oldest pointer forward. So it's like a circular. When you get to the end, and just modulo to go back to the beginning of the array. And this is increases the page file count. And then we go to the LRU replacement algorithm, and this one um, has the frame array as well, and it's treated as a queue. And the most recently used page goes at the end, and the least recently used page sits at the front. And so if the page is not in memory, then there's a page fault, and it removes the least recently used page, which is the front of the array. And the page is in memory, then it removes it from this current position and moves it um, to the end of the array. Okay, so we'll go ahead now and let's run the code and see which algorithm is more efficient or causes the less amount of page faults. Okay, so in this test, the FIFO replacement algorithm it created 562 page faults, and the least recently used had 332 page faults. We'll run it again. Once again, the FIFO produces more page faults. And one more time, we'll try this again.